Good morning, everybody. Can all hear okay? Perfect. Well, thanks for coming bright and early to the Saturday session. We're super excited to be at ISS and present to you all today. So we've got this little video and just want to start off with a couple of questions to be thinking about throughout. So what if you could have, prescribe, or make the perfect fitting wheelchair with every user every time? And what if measurements really didn't even play that significant of a role? Then what if you could also do this without sacrificing equipment weight, aesthetics, and most importantly, functionality? This morning, we're going to be teaching and you're going to learn a lot about the impact and benefits for end users, clinicians, and of course, manufacturers when designing assistive technology using design for manufacturing techniques. So I'm Tatiana. I'm the product manager of the Bowhead Aero wheelchair, but I actually started with Bowhead about 6.5 years ago as a co-op student. So it was a pretty funny story, but I met Christian in a hotel in Edmonton. He was there for a conference. And, after 15 minutes, I found out that I would be working in his basement on these crazy adaptive bikes. And that was kind of all I knew. But in my biomedical engineering degree, you have to do a internship that applies mechanical engineering techniques into a medical field. So I was kind of just satisfying that requirement. Little did I know that I had found my forever home and dream career. So that's me.
Yeah, and I'm Christian Bagg. I'm the founder of Bowhead, and I'm the guy who owned the basement that she worked in. So to go even further back, just some background on me is I was injured T789 paraplegic complete in 1996 snowboarding. I was a 20-year-old kid being a 20-year-old kid. And at the time, I was doing my apprenticeship as a machinist at the University of Calgary. So I was in the engineering department. I wasn't an engineer, but I worked in and amongst them. So I had kind of had this, a little bit of free education in just the spots that interested me. When I broke my back, it was pretty instant that I realized, while I was in the hospital, that I would be 100% reliant on technology for the foreseeable future. Anything I wanted to do, I would need to have something to help me do it. And in 1996, there were fewer things to help you do it. So it was pretty immediate where, from leaving the hospital, the people I worked with, we made a lift that would get me up the 4 stairs to my kitchen, but it worked off the city water pressure and sort of filled up and then emptied like a toilet. It was totally silent. It was super cool. And so it was that confidence from the people that cared about me that we could design and build our way out of these things. So within a year, I built my first wheelchair, and I never ordered one since. I've always been building them, designing things, and I'd made chairs. I'd made chairs for other people, but I really had a passion for the outdoors. And I wanted to get back to those places that I love so dearly. And that's where the Bowhead name came from, actually. It's the head of the Bow River, or the mountains that create that river. And that's where I injured myself, and that's where we endeavor to play. So, creating something, whether it's off-road wheels and then you'd go out a little bit, or a bigger caster, you'd go out a little bit and you could get a little further into the mountains, but there was a barrier where that just ended. And that's where the bikes really started. And I know we're talking about manufacturing, but it's a really important part of the story is to couch what we're going to talk about and how we got to where we are. And so the easiest way to do that, because our bikes and even our chair is kind of like describing an elephant to someone who hasn't seen one. It's way easier to see one than it is to talk about it. So without further ado, we'll give you a little video to give you an idea of who we are.
Yeah, so
Hi, my name's Sally. Today we are going to be showing you all about Bowhead's quad controls on all 3 of our bikes.
all right. So yeah, when we started in the basement, of course, we didn't have all 4 models of bike. We didn't have all the machines. We didn't have, we were a team of 3. So I remember still like having to cut the tube for the frame rails and then all of like our articulation. So the system out front that allows you to traverse uneven terrain. Yeah, cutting all that tube on his deck and then bringing it down because it was too long to just bring down into the basement. At that time, it took about, realistically, like a whole month to build a bike, but we kind of dialed that down in the basement to even like 14 hours, and that was a feat. But still, like as the word got out there, as other people started using the bikes, the demand grew, and before we knew it, we had like 10 orders and then 20, and we were like, all right, we got to figure out how to make this faster so that we can keep up with the demand. We also then, like, growing your team of riders, we started getting requests for different controls. Not everybody can manipulate a standard twist throttle or like a finger lever brake. So the current, like original model of the Reach that is fully electric evolved to get hand controls. From there, people are like, well, we want to be getting like more cardio. It's not that you don't get any workout from an electric bike, but they wanted something new. So that's when the RX came into play. But then again, that requires a lot of, skill and or strength and certain muscles in order to control the articulation. So that grew the Rogue, the Delta bike with one wheel in front. And then just a couple months ago, we released our fourth model, which is a 4-wheel platform that kind of actually takes our front half of the Reach, rear half of the Rogue, puts them together, and now you have a super stable platform that's still incredibly capable on the, world's terrain that is not level. So yeah, of course, like manufacturing had to grow, and then pretty soon we moved into a shop and slowly just started taking over more and more of the shop. And now we have a 14,000 square foot shop that is producing 20 to 25 bikes a month. We just launched the Era and already have 20 sales here. So yeah, all of our techniques had to grow. And then what we had learned from the bike, we had, I guess, the expectation from our customers to have a high quality product, super reliable, easy to service. And now we had to put all of that into a manual wheelchair. And it also had to be at that level of our 4 bike models. It couldn't start at the level of the Reach and grow because, we had proven that like we're already at this level. So you can't kind of go back from there. So yeah, we had the problem of trying to build a chair that needs to fit the user perfectly. Like fit is the most important. But how do you do that in a way that is then easy to manufacture and is repeatable so you can maintain that high quality? We couldn't afford poor customer service. We had to pick up the phone every time people were calling. And that just really expedited our growth. And most companies wouldn't be able to continue to launch new products every single year. But with our team and with our whole community of riders, we were able to do that. So this video here is from Kelly Brush Foundation camp, where there was 15 different adaptive riders, most of whom were on one of Bowhead's products. And then just another showcase of a rider on the Rogue.
Bumpy ground.
Yeah, it was really organic growth, learning from our customers every single day and making a platform that could grow. And we didn't have to launch 15 different models of bike that were servicing all of these different requirements and needs. How do we have one main platform that can grow and adapt and be modular?
So yeah, to bring back to manufacturing. So from, like Tatiana said, we started in the basement. As we grew and got more orders, we needed to employ some for a variety of reasons. And customer service is a great one to focus on. You need to employ better techniques. And this is true of the whole industry going back to the 80s and 90s when I was first dealing with adaptive equipment and really this slide shows all other industries did the same thing because anything on there, whether it's cars or bikes or planes, all started, in a proverbial basement. It was always someone's idea, even if it goes back 100 years. And everything really is driven by whether it's customer needs or safety or production, but they all come back to making a quality product. So even though there was a lot of passion in a basement and making parts, what you did was you ended up with some things where maybe the tolerance wasn't quite right, or maybe it wasn't exactly the same as the one that another person got. So as you grow, you get expectations from your customers, whether that's growth from a company that's already established at 1,000 units of something or 100,000 units of something. You know, if you get a Gillette razor blade, you don't expect one of the 10 to be dull. They're all sharp. They're all perfect. So this idea that designing for manufacture is sort of like a big company, maybe like, you know, an evil empire thing. Not that maybe some of you think that, maybe some of you don't, but it's not. It's really all about the customer and the end user and your patients. So the more advanced techniques we can put into something, or any manufacturer can put into something, then the better that product becomes. And that's really where a lot of our design focus went, because like Tatiana said, we're a small team. You can't be fielding all sorts of different requirements from all your different customers or patients. In the very beginning, when there's 1 and 2, you can, just like a custom bicycle. But it used to be, you know, custom bicycles would be the pinnacle of a bike. But now the pinnacles of bikes are the carbon fiber, you know, from a downhill mountain bike racer to a road bike racer. You don't describe their bike as a modular bike, right? Whereas maybe you would describe this as a modular chair. It's just because it's sort of new in this industry. But you would look at, you know, a Tour de France winning bike and say that's a race bike. But in reality, it is modular. It's a frame and a fork and a seat post that goes up and down and handlebars and all these things. And what makes it, and the reason they're not on a custom bike is because the engineering that you can put into modular components, if you know what you're making over and over and over again, then you're able to apply higher levels of engineering to those parts. If they're changing every time, you can never apply that level of engineering because you don't know what you're doing until you do it. So there is a lot of romance with it, but technology has sort of moved past that. And that's really what this represents, from golf clubs to bikes to skis. They're not to cars, to airplanes. They're not custom anymore. There are customizable components, but the foundations of them need to be built in engineering. And they're not built there for anybody but the end user, because the end user drives the market. So for us, as we moved forward and we grew from, you know, a few bikes to many, and we started employing these things, we knew we were on the right track, because at the big bike shows, so before we did sort of adaptive things, we went straight to the bike world. That's where we presented our products. And it was strategic in ways, but it was more that we were following a trend. We saw in manufacturing, we saw bikes, and we saw the people who rode them and the companies that made them, and the value that they were able to give at a relatively low cost. You know, not everyone here could afford a $400,000 car, but almost everyone here, if they wanted to, could get the world's best bike. It's achievable to grab that piece of engineering. So looking at that as an industry that really cost-wise paralleled this one. So how do we get this industry up to the level of bikes? And it was to immerse ourselves in that culture and in that world. So we have, it's not about sales numbers, but we have like 1,000 bikes out there, which is a really small amount of bikes. If you were a two-wheel bike company, that wouldn't be on the radar of any big bike company. But for us, because of this industry and because of people's compassion and empathy towards and their knowledge of maybe a friend who was injured or things like that, we have partners like Bosch and Continental, SolidWorks, that not only know who we are, but like our bike will be in the Bosch booth at the Sea Otter Classic, a big bike show, or we meet with the Continental Tire people from Germany. Like they're really interested in what we do because of who we do it for. And that goes back to where Tatiana was talking about the expectation of what we do. So the nice thing with designing for manufacture and getting to a level of manufacturing is you really can't go backwards. The expectation is there and you can only do better. So we've gotten to a level with our customers and the companies we work with that there's an expectation. And that's really where this chair came from, was that once we launched it as a 8-year-old bike company, we knew that it couldn't be out of a basement anymore. It had to be at the level that we've achieved. And luckily, serendipitously, through our bike relationships, we're able to like access a lot of that manufacturing that we wouldn't have otherwise. And so it really is, it's as much an end user story of trying to get to places that you couldn't get to or achieve a fit that you couldn't fit, as it is a growth of manufacturing. Those things paralleled each other. And the manufacturing side is invisible to a customer, or it should be. All they should see from advanced manufacturing is reliability and quality.
Which of course brings us to the Era. So the Era is fully adjustable. The width is adjustable. Seat height is adjustable. Center of gravity, of course. Wheelbase. Your brakes are adjustable. Backrest angle. Calf rest height. All of this is adjustable, which is or has been seen as potentially a bad thing actually in the industry, because adjustment may mean bigger brackets, a bulkier look, and heavier weight. And so we had to somehow make this adjustability, like the other industries that you've seen, be seamless and streamlined and beautiful. So the Era uses one size screw, one length, one type. So like any bolt that you see is the same. Building it, that means one bin of screws. It means one screw to order. All of that inevitably actually comes back again to the end user or the clinician or vendor who has to now fit the chair to the user, or then do maintenance over time, repairs. You only need one tool, which again, we ship every chair with that tool to try and enable and empower individuals to take care of their own equipment, and just, yeah, be able to try new things, try different fits. Because if you're only allowed or able to try a different fit or a different measurement once every 5 years, how do you really know if that's going to be the fit that you want? Here with the Era, you can try a different thing every day if you want to. So this also, like what we learned from the bikes, we had to then try and standardize components. And some of it came again, like through our knowledge of the bikes, but some of it was like a learned like, I don't know, just found it out in prototyping. So for instance, we have here our axle plug. This part can actually come completely out, and that's one of like the ways that you can change camber. But also when we were designing it, we had put these, I'll take it off, 3 different holes for that wheelbase. And it was meant for us just to like learn about the fit of the chair and to get different lengths for different users. And then once we would get the measurement, we would put in the right plug that either had the hole in the front, the middle, or the end. But then once we were testing and Christian was using the chair, he actually started utilizing all 3 holes in his daily life. I mean, he can speak more towards this, but essentially, like, even on the way here at the conference, he'll most of the time have it in that front hole, which is a tighter turning radius, a smaller overall kind of size for getting around. But then if you're dealing with steep curbs or going for a walk with his kids, he puts it into either the middle or rear hole so that you can get a like bigger leverage on your push and you're not as tippy. So it also then provides different access opportunities. So again, we were just in LA at another conference and he had to try and navigate the super small Airbnb bathroom. And funny enough, you would think, again, smallest wheelbase would be best, but no, as it turns out, he had to again put it in that rear spot so that he could fit like the wall in between both wheels. So that was something that we kind of stumbled upon, but it ends up benefiting the end user by adding functionality to the chair and then your daily life. Another kind of benefit, I'll put this back in, was our seat side guards, and then the application of either having a fender or not. We knew that not every user would want a fender, but if they did want it, or if you move and now you're in a wetter environment, now you want to add that. So it couldn't be something that was like, oh, okay, well, you want to add that, now you need a whole new chair. Sorry about that. We designed this slot into the side guard that allows for the fender to be easily added at any point. And then it also allows us to continue developing, like, who knows what a customer is going to ask for next, but, potentially armrests or a holder for something else. And now we have that spot in the chair to continue to innovate and create new solutions. So yeah, standardizing as much as possible just allows you to continue innovating quickly without, again, like the burdensome like increase in cost of buying new chairs and or new modules.
Yeah, so that actually leads backwards to the bike and really parallels, say, with the automotive industry in manufacturing. So our fourth bike that we came out with, the four-wheeler, is, like we mentioned in the beginning, it's the back of our third bike and the front of our first bike, and some things in between. But what it did was that forethought of, how far apart the frame is, which connections we're going to use, very more mechanical things that aren't customer or client facing, they allowed us to build off that platform. So there's probably a good chance that the car you're driving around that is new has the same chassis from a car that is 5 years old. So they'll do things so that you have a platform, a foundation that you can build off of. And that's what we've tried to employ here. So though we have amazing CAD partners, which there's the renderings on the left, our design does start, and design for manufacture doesn't have to start at a very high level. It's really anybody can do it. And that's what's being displayed there. Is the whole chair in this, for us, started with an acknowledgement that people have different wheel sizes, both on the front and the back. And obviously there's endless decisions to talk about as to how this chair came to be, but this is a really good example of sort of where those three positions came from and why the egg shape is the shape that it is. So the little pies represent the radius of different size wheels. So we knew that we needed to fit multiple sizes in the same zone, because from experience, caster angle can be a difficult thing on a wheelchair. So and from our experience of people coming in, often they had their angle wrong. It's something many end users don't understand. So they'll be cruising around the world with their caster at a funny angle and just not knowing it. And the performance of the chair will go down because of that. And it could be a good chair. That's the thing. So by not employing intelligent design in the beginning or good manufacturing, you can have a great thing that performs poorly because of the end user's lack of knowledge or maintenance or things like that. So the chair really started with, can all these wheels fit in that zone to keep the chair level? Then you move to the front wheels. People want 4-inch wheels and 5-inch wheels. Well, they both fit in your frame. And it really, what it does is it takes that romantic side of creating something for yourself, and it moves it into the, like, can we make this? Can we reproduce it? Because the better, and can we lessen the amount of parts we do need to make? So that's why obviously you could make it for one size wheel, but then maybe you would need 3 different frame sizes for 3 different wheel sizes. But then you've got different footrest heights. So now you need to multiply that. And you end up down this rabbit hole of needing, if you're using composites, 20 different molds. Well, 20 different molds ultimately costs a lot of money, and then that gets handed down, and the whole thing spirals into not being able to be achieved. And the person that loses out is the end user because they don't get the thing they want. So by thinking about the manufacturing process and how you'll accomplish a lot of things in one space, you make a high level of technology available to someone because you, as the manufacturer, can afford to do it. So now, with all the wheel sizes fitting in one shape, that means we just need one mold. There's a different machined part for that goes in the ends, but that's a lot easier to accomplish. So it's looking at different manufacturing processes, whether it's machining or composites, and choosing the right way to design your product around those things. So using adjustments allowed us to mitigate the need for molds, different sizes of things. But then you've got to, and then it gives you the time to focus on, so your clamping tolerances or the size of your clamp or the design of your clamp such that it doesn't squeak or it doesn't move. I mean, a car is made up, I don't know how many parts. You could Google it. I bet there's 1 million parts in a car if you counted all the screws and all the pieces. And your car doesn't fall apart after a month, right? So like, and we really got that confidence from the bikes, because each bike has about 1,000 parts in it. And our bikes, as you saw in the beginning, go down mountains, and they need to be safe and they need to be reliable, because not only do they go down mountains, they take people into the middle of nowhere and they have to be able to get back. And in the very early days, we got calls of people in the middle of nowhere in a different country asking us, like, what do I do? So that really forces you to think about how to make something consistent and quality. And it's really hard if you don't, to know what that person stuck in the middle of nowhere is on. At least if you make it consistent, you know what they're doing, you know what bike, you know how it's made, you know what screw is used, you know how to advise them. So it really, the very beginnings of a product should be designed for manufacture, because it allows you to put more time and care into each part because you know what it's going to be. And you can test it. So like clamping forces for the seat post, we always know the diameter, we always know the range, we always know the materials, we know the tolerances. So then you can consistently test it. And if it fails, you can change something, and you know that when you change it, it will continue to be that way. And that's how you end up with a user experience, I guess, that is high level in quality and consistent, and they enjoy your brand and they enjoy their experience, and they know nothing of the seat post clamp test, and they never should. So it's really, like I keep going back to, it's not a negative thing, and it is intrinsically linked, manufacturing and the end user.
Before we hop into a little bit more on carbon fiber specifically, I just wanted to touch back on like the operational side of things. So yeah, before I was managing this product, I worked a lot in assembly and operations. And like we were saying, to get a reliable, safe, high quality product every time, that has to translate down to the people actually assembling the product. And how do they do that? Without instructions. But again, if you have unique instructions for every different size, it's hard to develop those, and then it's hard to keep them up to date as you change things. So again, with the modularity, you can have one set of main instructions that then just kind of shows you like, all right, this is the basis, but then if you have this variant or this variant, these are those specific steps. It also then goes all the way to like ordering parts. And if you need a certain number of parts every month, having hundreds versus tens is obviously a lot harder to manage and harder to keep control of the shipping time, and also just keeping costs down. And then, as Christian was kind of mentioning, all the tolerancing and all the engineering that goes into different pieces, and using different techniques. Like if we go just back to our rear clamps here that hold on the axle tubes. These ones are kind of our like most simplistic basic clamp. There's nothing added to it, but by just simply replacing this piece here, you can now add functionality for a rear power assist device or anti-tippers. And then you aren't stuck with that again. You can change 2 small clamps over time that, you know, don't have a price on them yet, but maybe that's $50. And you can have this chair when you're first coming out of rehab with all the safety requirements that you might need. But then as you learn and gain your skills, you can take that off. And now you're shedding weight and just, yeah, it enables you to change and modify and grow your product as you want. Another key features are removable seat. So this really like, again, splits the chair so that we could worry about all of the performance characteristics and geometry of the chassis and setting up our casters, like Christian mentioned, without the need to adjust angle. And then all of that is accommodated in all of the other parts that we've designed. Then by having the separate seating module, now you can have like an office seat or a gaming seat, but then you're not stuck in like a higher backrest and armrests all day. You can still transfer into your kind of low profile going out and about chair or seat. And again, it's like maintaining your investment over time. In this one, it shows our sport port adapters, which in the middle photo, it's just that little added block, which is put in with a quick release pin. So no tools, and you can transition from your daily chair at the top to a recreational chair at the bottom in a matter of 30 seconds to a minute. That allows users who aren't necessarily team sport enthusiasts or just really somebody who's wanting to try basketball or try tennis before committing and buying that full sports chair and joining the team. Now you can just recreate, or you can learn what you like before committing.
And then a little bit about composites, because I don't know how many of you were in the composites talk the other day. But does seem like a bit of a maybe not a buzz. It's a newer thing in the adaptive space, slightly. And a lot of the questions about composites, I can imagine, would have been asked 20 years ago at a bike show or a golf club show or a tennis racket show or anywhere else that has been using composites for that long. So just to give a really rough rundown, and the video is kind of showing you. So carbon fiber, if you've worked with paper mache, you understand carbon fiber. So it's cloth and glue, essentially. At the basic home level, it is exactly that, like a woven sheet of cloth, whether it's fiberglass or Kevlar or carbon fiber, it's like the clothes on your back. It's a woven fabric. And then you mix glue into it, the epoxy into it, all sorts of different types of epoxy, and I squeegee it in. I do a lot of the work, or I did a lot of the work. So you wet it out, you get it saturated with glue, and then you use layers of it around a mold or inside a mold, or some way to hold the shape of that cloth. So then you end up with your shape. If you test it and that shape is too weak, it's a really interesting and great material compared to metal in that way, because that same part you can put more cloth onto and make it stronger in the area that broke. So that's really a, no pun intended, a strength of carbon fiber or composites, is that you have a really good control over your thing, over your product. So going from what's called a wet layup there, because you've got the wet epoxy, then you end up with pre-preg, which they talked about the other day, which is pre-impregnated cloth with epoxy. So it just means that a machine that's much better at determining the ratio, has squeezed that epoxy in, and it sits in that cloth in a refrigerator, not curing until you need it. And then you unroll the cloth, it's already there. and you're able to cut the pieces better because they're not a soggy, wet piece of cloth. And you can determine where they go in your mold or on over your mold more easily. And so that's why composites make for a really good manufacturing material. And that's why bicycles are made out of it, and golf clubs and hockey sticks and tennis rackets and all this. It's not just because it's high performing, it's because it's very manufacturable and very easy to control and learn and move strength around. So, for example, on our chair, the wing up front, the sideways bit that holds your feet, it's basically like a pretty big long leaf spring. So it can, if you can imagine, if you loaded it up, it would flex. So you need a lot of cloth through this area, and then, but maybe back here where it's really big and voluminous, you don't need as much cloth. So you can move it around. You can also, because it is a very light and strong material, you can start on a very safe end, which is what we've done. And so you have a lot of material everywhere. And then as we go through the years, I'm sure we'll take material away. And that's how, without the look changing, because the outside of the mold remains the same. And that's how products in a lot of other spaces, and not to say there hasn't been innovation in this space, but there's certainly been less innovation in this space. I think if you look at a wheelchair from 1984 when Reiner Kuschall made a cantilevered frame and some current ones, there's not a lot of difference. In fact, a lot of lay people won't be able to pick which one is new and which one is old. Whereas if I show you a toaster from 1984 or a tennis racket or a dress or a car, anything, you're going to be able to identify. So there has been a little lack of innovation. And I think some of it is going away because of new materials and an understanding of them. I say new materials only in this space. They're quite old materials in any other space. And so, but it gives you a consistent part over and over. It's just, how do you do it? And that's where it goes from manufacturing to design, is how do you take something? Bikes are actually quite easy. They're a 2D thing. They just account for someone's height. Wheelchairs are quite difficult because you've got width and depth and disability, and a variety of all those things in every direction. So it's a bit more of a puzzle, but it's still a puzzle that can have innovation. Doesn't mean that you have to throw the baby in the bathwater out with all the other products, but it means that you're allowed to do things differently and move forward a little bit. And to do that, we really did have to lean into design for manufacture, because although it's fun to sit in my basement and lay up cloth, it's not achievable on a larger scale, and it does not help the end user one bit. So now we have molds, we have thought behind it, and what I thought the beautiful chair that I made in my basement, I don't even use now. It just sits there. It's essentially hundreds of hours of garbage. So, and that's where manufacturing can take you. Even if you care deeply about something, you recognize that the thing that you can engineer and come off of a mold is ultimately better than the handcrafted thing that's made to measure for myself, by myself. So there's a little bit about carbon from our end for anyone that was in that talk that wanted a little easier explanation. And there you go.